lesson 27, surface area of 3D figures. So in order to find surface area, you need to find the area of each surface and add them all together. Okay, so this requires a bit of out-of-the-box thinking a little bit. Say we have this figure here. This is like a typical box. However, we don't see every side of it, right? Think about if you have a box of tissues. How many different sides would there be? So we have this front side here, this top side, and then this corner. But don't forget there's also a corner on the other side. There's the bottom of the box as well as the back of the box. So if you think about it, there are 4 going around the center, right? This would be, I'd have 1, 2, 3 on the back and 4 on the bottom. And then I have 2 on the side. This is my 5th side and my 6th side. So another way to think about it is kind of breaking it out into a net. And a net is a flat image, and if you were to cut it out and fold it, it would make a box. So like this would be the front, these would be the 2 sides, this would be the back, oops, not 5, sorry, that should be 4, and then these would be the 2 corners of the boxes. Okay, so when we are finding surface area, all we would need to do is find the area of each one of these boxes. And once we know the area of all 6 of those boxes, we just add them together. And that is our surface area. However, in order to find the area of those surfaces, you need to know your formulas. Okay, so area of a box or rectangle is base times height, and area of a square rectangle is base times height, and area of a triangle is 1/2 base times height. So you need to know these. If you don't know what these are, then you cannot solve these problems. So write these down somewhere, have them somewhere where you know where you can find them. Alright, so let's get started. We want to know what is the surface area of the figure below. Okay, well, let's kind of look at each of the sides. So I have this big front side here, this big front rectangle. This slant right here is 5 centimeters and this bottom side is 6. So for this big rectangle, I would have 6 times 5, which would give me 30. And then let's look. I have this triangle here, and I also have another triangle on this side that is the same size. So this is 4 centimeters and this is 3 centimeters. So let's do 1/2 times 4 times 3. If we were to type this into a calculator, we would get 6. Then I have the bottom box here. Now this side tells me that it's 3 and the bottom tells me it's 6. So I'd have 3 times 6 for the bottom, which is 18. And don't forget that I have 2 of those triangles. So this triangle here, I need to multiply this by 2 because I have 2 triangles. So this 6, I need to multiply by 2 to give me 12. And then the very last side of this triangular prism is this back box, right? My back rectangle. Now if this front side here is 6, that means this back side is 6, and I have a height of 6 and a height of 4, here's my 4, and a width of 6. So the very last area I'd need to add together is 4 times 6, which would give me 24. So I have 30 plus 12 plus 18 plus 24, and we can pop that into a calculator. Plus 12 plus 18 plus 24, which gives me 84. So the surface area of this triangular prism is 84, and it would be centimeters squared. So again, we're finding the area of each surface and adding it together. Alright, next one. So here we have a box, and we want to know what is the area of the figure in square inches. Now notice how we are given feet here. Before we start finding the area, we need to change all of our units into inches because that is the unit that my question is asking me. So in order to do that, we would take these feet units and multiply them by 12 because there are 12 inches in 1 foot. So 0.5 times 12 would give me 6. So this bottom side is 6 inches. And 1.5 times 12, if we typed it into a calculator, would give us 18, which means that this length is 18 inches. So now let's start figuring out what the area of, or the surface area of this box would be. So I have this one corner here, and if I were to think about a box, this side over here, I would also have another one of those corners. So I'd have two corners that are the same exact size. So I would have two corners that are both 4 by 6. So the reason why I have this 2 here is because there are two rectangles that are the same size. Okay? Then let's do this front box here that I'm outlining in yellow. I would have another one of those way back here in the back. And they would both be the same size. Now, since this corner, this side over here is 4, that means that this side over here is also 4. So when I am multiplying these, I would have two rectangles that are both 18 by 4. And then let's find our very last one, which is going to be the top and the bottom. So this big box up here, and then also the same big box that is on the bottom. So again, I have two of these, and this is 18 by 6, right? 6 is on the bottom here, which means 6 and 18. So I'd have 2 times 6 times 18. Okay, so I have all of my areas written out for each of the boxes. Now I just need to pop this all into a calculator and see what I get. I don't know why I keep hitting the plus. And then I have 2 times 18 times 4, 2 times 6 times 18. Let's add this all together. So 48 plus 144 plus 216, which gives me 408. Whoops. So the area of this figure would be 408 inches squared. And it is so important to make sure that you are changing your units before you start multiplying. So you need to pay attention because you have a few questions that are like that. Okay, if your question is asking you for your answer in inches, you need to make sure that all of the numbers on your figure are in inches. Okay, next one is a composite figure. So we have these two boxes that are thrown together. And if I were to cut this box here, right here, you could see how I have this bottom really thin flat box and then another box that is placed on top. So we need to find the surface area of both of these and then add them together. So I have, let's start with this top box. So this 4 by 8. So this top side is 4 and this down here is 8. If I look down here, this long side is 20 centimeters, which means that this long side here will also be 20 centimeters. So let's use that to start finding the surface area of this box. So if I look at this top side here, I'm going to have that same side on the bottom, like this. Okay, so this is a 20 by 4, and I have two of those. Then let's move on to this big side. This is going to be a 20 by 8, and I have two of those. And then let's do our last side, which are these corners. And these corners are going to be 4 by 8. 4 by 8, and I have two of those. Okay, so that's that top box. Let's move on to the bottom one. On the bottom one, let's do the big one, this big one here. So it goes all the way back. It's cutting into our original one. Now this side here is 14 and this is 20, so I have two of those as well. Let's do a corner. Let's do this small corner over here. I have two of them because it is a box, and I would have 20 times 2. And then the very last one is going to be this edge here. and this is 40 by 2. See how I have a 2 over here? That means that this side right here is also going to be 2 centimeters. So now we gotta multiply all of these and add them all together. So bring back that calculator. So 2 times 20 times 4 plus 2 times 20 times 8 plus 2 times 4 times 8 plus 2 times 14 times 20 plus 2 times 20 times 2 plus 2 times 14 times 2. Alright, so that gives us a grand total of 1240. So surface area for this composite figure is going to be 1240, or 1240 I should say, centimeters squared. So again, you're finding the area of each surface and adding them all together. Alright, next problem. So here we don't have to find we don't need to find the surface area here. We need to kind of figure out what Raylan did here to make a mistake. And it says that Raylan needs to find the surface area of the following L-shaped composite figure. She multiplies 7 inches by 10 inches to get the area of one side, which is 70 inches squared, and then multiplies that by 8 because there are 8 surfaces to this figure here. Is her solution correct, yes or no? Well, first of all, I'm going to say no right off the bat because she is using feet and inches and she didn't convert all of them into inches first. So right off the bat, the ones that say yes, she's correct, I'm going to cross off because I know that she is not correct. Now let's read the reasoning a little bit deeper and see why. If we notice, not all sides are 7 by 10, right? Here's 4 inches, this would be 6 inches, and this would be 12 inches. So no, she did not measure all the sides the same because they don't all have the same area. So when you multiply 70 by 8, that's not correct because each side has a different length. So not all faces have the same area. Alright, next one. So Jake is wrapping a gift in a box that is 12, 4, and 8 inches, and Havana is wrapping a box that has all the same dimensions but they are twice as long. We want to know how many times larger is the surface area of Havana's box compared to Jake's box. So for this one you might want to say 2 because it's twice as large, however that is wrong. So let's actually figure out the surface area and see whose is actually larger. So let's start with Jake's box. So let's roughly, I'm going to try my best to draw a box here. Okay, and we have 12 by 4 by 8. Okay, so that means that there are going to be 2 sides that are 4 by 8, 2 sides that are 8 by 12, and 2 sides that are 4 by 12. Okay. And when we multiply all of these, this would be 2 times 32, 2 times 96, 2 times 48. Let's pop this into a calculator. So 2 times 32 plus 2 times 96 plus 2 times 48. So Jake's surface area is 352. So this is Jake's. Now let's find Havana's. So her box is going to be exactly like Jake's, however hers is going to be twice the size. So that means this would be 8, this is 16, and this is 24. So we're going to do the same process. Just with the larger numbers. And then popping it into a calculator again. So, let's see, I have 2 times 8 times 16 plus 2 times 16 times 24 plus 2 times 8 times 24, which gives me 1,408. So clearly it's not twice as big, right? Because if it was double, this Havana's surface area should be something in the 600s, but it's not. So to figure out how much bigger it actually is, we're going to divide our surface areas. Okay, so we're going to divide our surface areas to see how much bigger Havana's actually is compared to Cheeks. So 1408 divided by 352 gives us 4. So Havana's surface area is 4 times larger. So we would want to put a 4. So 4 times larger. Alright, last example here. So Rachel is placing a protective cover on a glass case. The glass case is a cube and a perimeter on one face of the cube is 56 inches. How many square inches of protective covering does she need for her case? So here is her cube. And I know that the perimeter of one of my faces is 56 inches. Now perimeter, remember, is all 4 sides added together. So if I have a square, and if I were to add x plus x plus x plus x together, I would get 56. So to figure out how big or how long one side of this cube is, we need to divide 56 by 4. And when we divide 56 by 4, we get 14. So that means that each one of these sides are going to be 14 inches. So now that we know that each side is 14 inches, what we can do is find the surface area. And with a cube, it's actually really nice because if you think of like a dice, there are 6 sides on a dice, right? And the area of one side is going to be 14 times 14 because it's a cube. And since all 6 sides are going to be the same exact size, then all we need to do is take that area and multiply it by 6. So 6 times that 14 times 14. And when we multiply it, we get 1,176 inches squared. So she would need 1,176 inches or square inches to cover her cube. Alright, and that is all I have for lesson 27. If you have any other questions, please let me know. Have a great rest of your day.